Hello, this is Scott again. So this is the final video in the predictive analytics readmission surgical site infection series that I'm doing. And today I'm going to present the weight of evidence. It's a very important way to avoid black box models. So there's a growing concern that data scientists are using AI and machine learning, artificial intelligence and machine learning, and they don't know exactly what their models are doing. And if you'll remember back to the Great Recession, that's exactly what was happening with the finance and CDO models, mortgage bundling models, is that no one really understood what was going on, and obviously there was a severe impact. So once again, I'm demonstrating the power and importance of machine learning in healthcare. So after a few more introductory comments, I'm actually going to show a demonstration of weight of evidence in action. So again, the focus here is weight of evidence and rules creation, and you can see my two previous videos on predicting surgical site infections for both number one was model building and number two was deployment. And so I'm going to assume that you know a little bit about the data here. I'm not going to be spending a lot of time on the actual data from University of Iowa health hospitals and clinics here. So this is a very important way to interact with your data. And so as I was saying, it allows for model transparency. So we're going to understand exactly how we are binning. We're actually going to control the binning of continuous variables, the binning of categories based upon weight of evidence and information. This really applies to a binary target. So, for example, disease, no disease, surgical site infection, no infection, etc. So a binary target is what we have, readmission, no readmission, etc. So I'm going to make an attempt to make this video as short as possible and get straight to it. And then I really plan on doing maybe a series on weight of evidence, maybe a three-part series to show more of the underlying foundation, some of the math and why it's important, and how it actually will beat out a simple logistic regression model by using a combination of weight of evidence plus logistic regression to get better results. So the two of the objectives here, or two of the impacts here, is upon regulators wanting to require conditions to be explained transparently. Weight of evidence has a big part in the financial services industry, understanding those credit score models, etc. And then also, researchers and subject matter experts need to be able to explain how a model is arriving at the set of conditions, or the arriving at the results or answers that it is. And again, as I said, it can provide more accurate results than simple raw inputs, and it'll also help you in handling missing data as well. So the things that I'm going to cover in the demo today is essentially the weight of evidence interface and TIBCO Statistica, creating those bins and everything for continuous categorical predictors. We're going to look at interactions of those predictors as well, the different types of restricted models, the ability to do custom splits as well, and then producing rules from this weight of evidence interface, and looking at under the hood, what the weight of evidence coded values are, and then a simple workspace, and using these rules within a workspace today. Okay, so if I go to Statistica and I have the the data set that I've been using, right, for unplanned readmission here, where one is an unplanned readmission, and then the different predictor set that I have. And again, see video number 1 for an explanation of all of these different columns. But what I want to do is I want to apply weight of evidence. So here's the actual platform. I'm creating a workflow, and I'm going to use the weight of evidence node here. I'm going to pick my variables. So unplanned readmission is the dependent or target variable, and I'm going to just select one continuous predictor for brevity and illustration, expected blood loss, and then I'll select wound class for the categorical predictor. So once I do that, I just need to tell the platform what is a good and what is a bad. Again, 1 is a readmission, so that's technically a bad. So I click OK, and now we have the platform ready to compute. So I can compute my groups. And then what happens is I look at the variables here, and it gives me a host of different relationships between this predictor, expected blood loss, and unplanned readmission. So there's a no restrictions model, which basically creates bins without any constraints whatsoever, and that's obviously the most complicated model, right? These are the number of bins. You can see here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 different bins that it created. And here's the relationship. So we start to go down, then up, etc. And what it's trying to do is it's trying to maximize the purity of goods and bads in these different bins, right? So it creates the Gini coefficient, right, which is a measure of purity, the information value itself, an underlying weight of evidence code, and then the boundary for the bins. So this first bin goes from -infinity to 450. Then the second bin goes from 450 to 550, etc. Now, if I'm a researcher and I know that this looks like a spurious, I might be overfitting with this relationship, right? I'm taking in the fringes, I'm taking in the very nuances of the data. And I know that's scientifically incorrect, and I want to see more of a monotonic solution, right? So a slope value, and I want to maximize the information, my cut points essentially, then I can use this monotone solution. There are some models where I may one minimum, one maximum, a concave relationship is acceptable, and I may, as I go through here, I get more complex relationships. Again, the thing here is to go with what's in the literature or subject matter expertise, and to not overfit the different models here. And so I can basically select the solution that I want here for my data. So here I've selected the one minimum, one maximum, which would result in 5 bins for this value, or this predictor, and then the different weight of evidence coding. And this is important because in the end, I'm not creating the category, I'm actually coding a numerical value to that bin. And that's how we get the lift from the model, is not creating a discrete variable, but actually creating a coded weight of evidence value. So that's very important. And then let's take a quick look at the wound class. Again, this is a categorical variable. And so when I look at this solution right here, the no restricted solution, what I see is that the platform recommends that I lump the wound class 0 and 1 together, and then I create another grouping of wound class 2 and 3. And so a lot of rich information here. Again, I won't go into too much detail for this particular video. Just one last thing to say is if I have this continuous variable and I want to actually customize the groups, maybe there's literature that I'm trying to follow, a recommendation, a protocol, a standard, a rule, whatever, I can define all of these cut points and make them what I want, right? And it gives me the weight of evidence across the different values within this grouping. So I can look at that proportion. There's a lot of rich information. The bad rates in this particular portion of the split, as I change that, I can see the bad rate changes. I can see the weight of evidence here, the differences, et cetera. So very rich information within the platform. And again, I hope to follow up on that at some point. The other thing that you can do is you can create interactions, right? So if I want to interact the expected blood loss and the wound class together based upon my 6-group solution here for expected blood loss, and then the 3 categories for wound class, I can look at that as well. And if I hover over it, I can see that the weight of evidence coding for this particular interaction is 46.74. Red is the highest absolute value weight of evidence. These blue ones are in the middle, and then the green ones are on the lower end. And so I can create that grouping, and it becomes becomes another predictor within the set. So this is the interaction effect. I can see Kolmogorov-Smirnov, I can see Summers-D, all of these different statistics. For simplicity, I won't add this. I'll just basically take this one off for this particular value. So the next thing that we can do is we can generate the rules for this. And so if I click on rules and I say rules for all variables here, since I'm just illustrating 2, we can really see what weight of evidence is doing. It's essentially creating logic if expected blood loss is less than 85, then create a label called, 850, create a label that expected blood loss is less than 850, but more importantly, it's actually producing a weight of evidence numerical value of 46.7 here. So I can see that all these rules are constructing different weight of evidence values, and I can use those rules within a workflow. So let me show you what that looks like. So now that I've set my rules the way that I want them, if I just close this out, I can apply those rules into a workspace. So now when I double click on this, I could specify again, or like we just basically what we just went through, or I can apply coding. So I'm going to generate rules node on node run. So I click OK, and then I generate these rules. And I need a source of data. So let me just, for brevity, I'm going to copy down the same space that we created these rules, and then I'm going to run these against this. Actually, I want to do one additional thing. I want to look at the rules, right? These are the rules that are being created. And then I also want to specify what variables to copy. So I can determine what variables I want to pull downstream. So I'm going to bring the existing variables across plus that new rule. And when I do that, I get this. I get the original set, and then these two additional variables based on expected blood loss and wound class. This looks like a categorical, just a bin, all right? But what I was explaining is this is really not just a bin. This is actually a numerical value. So if I go and I remove the text label and I actually look at the value that Statistica would use for model building, I can see these are numeric values. And so that is the power of weight of evidence. It's not creating discrete bins. It's creating a label for a user to easily see what the logic was, but it's actually the weight of evidence code that is in the platform. So given this, what I can do is, now that I've got my weight of evidence codes, I'm going to show you what the next step would be, which is essentially doing what we did before, right? We trained up several different models, and we did that with a workflow. But now I can apply the rules, which I can deploy off in various different forms. Again, deployment was covered in video number 2, but I can look at the rules that were created, right? And then I can use that for my model building process. Here for illustration, I just have a boosted tree and a cart model. And then once the code is generated to score future, I just bring in new patients. I apply the rules just as I would here. And then I can deploy against models and compare different models. And then now I have, instead of training up on raw values, I've got weight of evidence coding that a researcher can defend, or in the case of a regulator, you can defend that as well. So what did we cover? We talked very briefly about why we would want to use weight of evidence for model transparency and reproducibility, and actually more power and the ability to handle missing data easily. And then we went through a brief demo on the creation of weight of evidence and rules. So hopefully that was meaningful to you. And next time I'm going to switch gears. I'm going to be showing R, and I'm going to do a series of forecasting videos. I'll probably do a few, take a break, and do a few more, but I plan on doing a dozen or so different time series forecasting videos, all in R and R Studio. So hopefully you'll join me again. And if you have any questions or anything, suggestions, I really would appreciate suggestions on how to improve the series, and anything that you would like to see as far as machine learning, advanced statistics, or artificial intelligence, etc. Please let me know. So thank you very much, and have a great day.